Welcome back to lesson 10 of the Java tutorial series, and today we're going to cover polymorphism. Now this is probably going to be the shortest video of the series. Despite the long and complicated name of polymorphism, the functionality of this is actually very simple. And on the plus side, we did all the heavy lifting in lesson 9, aka the previous episode, where I spent about 40 minutes talking about abstraction, interfaces, and inheritance. So basically, this is just a little neat tool. Basically, it just served as an add-on of lesson 9. So without further ado, let's just get straight into Eclipse here. Again, super short tutorial. Just let you know that there's this advanced feature called Runtime Polymorphism. So we're gonna head over. Alright, we just have a blank canvas. Again, we're kind of back to square one here. Just have that comment reminding you that from now on we're gonna call them methods instead of functions and fields instead of variables. So basically, we are going to define all our classes inside this one main function because it's, again, super short, super sweet. So we're going to talk about runtime polymorphism. It is also known as dynamic method dispatch. It's basically a process in which a function called to the overridden method is dissolved at runtime. So this polymorphism is achieved by overriding the method. So we remember that annotation last class. We talked about that annotation where we did the at override. Yeah, that's gonna come into play here. So let us create a class here. So we're just gonna create a short and simple class called class parent. So let's do class parent, and we can do void. Since there's no public or private, we're in the same file. It doesn't matter. We don't need private or public or all of that. So we just do void print, and it says print system.out.print line. And let's see, what should we print in this class? We can just do just print its name. Let's just do parent class. Again, this is all very simple. You should know how all of this works. So we can do class child1. Now child1 void print system.out.print line. We're just doing some setup work here, and not actually going into any polymorphism yet. We're just setting up our classes, making sure everything is working. So obviously we have to do the extends, because I will say right now, the extends keyword does work for non-abstract classes. So last class we talked about abstract methods and classes, but you realize that extends can also work for pretty much any single class. Abstract classes are just for abstraction, but if you can see, we have this green triangle which tells you that it overrides this, or we can add this override. Again, it doesn't really do anything, but it's a comment. It's basically saying that you tell the developers you're working with that this method is overridden. You can see it has the same tint, same color as the comment, because that's all it is. It's just an annotation. It doesn't actually do anything. But I'll put that there so that other people will know what you're overriding. So that's why you put that there. Class child 2 extends parent. Again, parent can be totally an abstract method, but we can also make it a normal method too. So override, and then we do void print system.out.print print line child 2. So we have both methods here. Both of them are overriding. Now let's actually do some polymorphism here by creating some objects. So we can actually create this object called parent. So let's just declare. So parent object Alright, now we can reassign the object to be a new subclass. So we can do, first of all, let us do object.print, and put that over here. You can see, got initialize it to equals new parent. There we go. And now once we run it, you can see we have parent class, because that's just the default parent class. Now we can actually change parent object to new child 1, and it will still work. Now this is polymorphism, because polymorphism literally comes from the word meaning multiple forms. Because if you remember morph, you can morph means forms. You can morph into like objects and stuff. Morph, and poly is the Greek prefix for multi. So multiple, morphing, multiple forms, and same thing with here. This object can take on multiple forms. In fact, it can take on child 1, and once we run it, you can see it's child 1 class. And you're like, what is going on here? Well, remember from the last class, I promised I would tell you, because last class we did the thing with the employee and the salary, yeah. So this is basically the same thing. Because usually you're used from lesson 7 to define like this, which is also absolutely 100% valid. But you can see that we can also do it like this. But this will be wrong because child 1 does not implement child 2. But if we do child 1 extends child 2, so let's just do child 2. And now, class body. Let me see. Oh, right. We have to put this up here because it's not defined yet. Can you extend both classes? I don't think so. All right. So, anyways, as I was saying, you can do this, and it wouldn't work because type mismatch. You can't convert child 1, child 2. But what you can convert is from parent to child 1, because it's overriding whatever it is in parent. So basically, again, I'm talking about inheritance. Polymorphism goes all the way back to inheritance. Think of child 1 inheriting parent's genes. So the object is of parent 1's class, but it can take on the form of child 1 or 2. Because if we run 2, you can see that prints child 2, because basically what it's happening is the parent's gene, just that plain old void print. Then the child gene overrides the parent gene, and then it does child 1, but it extends parents. Again, the keywords is extends. So that is pretty much it for polymorphism. So again, this seems pretty much like a review of last time, which was all about the interfaces and stuff. So if we can get like an interface here, so we can do interface interface ancestor. So you can see that, let's say we have an ancestor interface, and our ancestor interface is void print. So you can see the parent will get its function from the ancestor class. So interface, I mean. So we can do implement ancestor, like so, and you can see change this to public because the interface. Yeah, so I'm just gonna change everything public because the interface is making it public. So, but naturally, again, implements, extends, same thing. Implements just a version of the interface. You can see if we change this, everything is inherited from the ancestor interface. So we do ancestor object equals new child 2, and it still works because if you look at that, child2 overriding, let me just reformat this real quick, overriding parent, and parent is implementing this empty function called print from ancestor. So that, again, very similar to last class. Again, you might think it's pretty redundant, but nope, there's a few little differences, especially with the child and parent and the implementing. But from last class, you'll see that this is actually polymorphism in action. Last class, we did this interface object equals new class sort of ordeal. But in this class, you will know that you can also make it the class of one class the declarator of a new constructor of another class. Pretty confusing, huh? But not really. If you take a look at the code, everything will make sense. So you can see, again, object's parent, object takes parent class, but it actually overrides it with the child constructor. So that is pretty much polymorphism in a nutshell. And if you enjoyed this video, please leave a like and subscribe, and I will see you in the next one.